like trying to prove Einstein's theory of relativity.
I know what you mean. This place is kind of weird, too. I mean, where are these utensils?
They got good music, though.
Benvenuto a Bernoulli's Bistro, purveyor of fine Italian cuisine. Let me pour you some water. Or H2O, as we like to call it. And let me tell you about our special today. We have a torta di formaggia, prepared with fresh pecorino romano cheese, portobello mushrooms, Kalamata olives, extra virgin olive oil, and of course prepared with a special home recipe tomato. Exactly at 300 calories.
That sounds good. I think I'll have that.
Excellent.
We wanted to.
Ooh, that's all we had in the kitchen. Good thing they ordered that.
Oh my God! It's a bug! It's a bug! It's a bug!
I
Get the
got
bug!
it.
Get it!
Ah, what's all the commotion? What's going on over here?
There was a bug on the tablecloth.
Yeah, do you think we could get a new one? It's kind of gross.
I'll take care of this using the power of physics. Stand back.
Whoa.
That was pretty cool.
How'd you do that?
Newton's laws allow for wonderful things.
Hey, waiter. We don't have a tablecloth now, though.
Oh,
Can we maybe sit somewhere else?
sure, of course. Follow me. Right this way, right this way. All right. Our last table in the house that has tablecloth anyway. Sorry we ran out of normal glasses, but these should be fine, and I'm out of matches as well, but you can imagine the fun. Yes, I'll be right back with your food.
All right, thanks, waiter. Hey, now that he's gone, I want to try it.
No.
Oh, come on!
No.
That'll be fun!
No, you're gonna make a mess.
It looked really easy.
No, I don't need you to do it.
Oh, come on!
No.
Yeah.
I can't believe you would embarrass me like that in public. I can't see this going anywhere.
Babe, come back! Come on! Oh,
Una torta di formaggio, pa-
I tried to do it.
I see. And how did that go for you?
She left me.
Yes, they always do. Well, would you like your dinner, sir?
No thanks. Can you just explain to me how to do this?
Oh. Well, sure. It's really very easy. Why don't you come with me over to the blackboard?
All right, thanks.
I can't believe you spilled pizza sauce on yourself.
Dude, it tasted good. It tasted really good. Hey, I got one question for you, though. Why is there a blackboard in the kitchen?
Well, this isn't the first time I've had to explain this to someone, you know. So let's go to our diagram here. Here we have a schematic of our table and the object upon the table and the tablecloth. All of this can be explained very easily by Newton's 3 laws. Newton's first law says that objects moving at a certain velocity, a constant velocity, will remain at that velocity unless acted upon by an outside force. In this case, of course, our object's at rest, so it's going to remain at rest unless something happens to it. So let's look at some of the forces that are on it. We have the force due to gravity pulling downwards. And that's exactly balanced out by the force called the normal force, which is going upwards. This is the object at rest. Now when we pull the tablecloth, we're applying a force in this direction, so we'll draw an arrow this way. We'll call that Ft. Now there's a force opposing Ft called the frictional force. Let's go over here and we can talk about that. Frictional force, F sub mu, is equal to the constant mu, which is just different for each material that you're talking about, times the normal force. In other words, it's proportional to the normal force. Now since the normal force is exactly the opposite of the gravitational force, this is just equal to mu times the mass of the object times the acceleration due to gravity. In other words, it's constant for an object of a certain mass and for materials of a certain kind. And very simply, when you apply this force, if it's a very small force, then it's not going to be large enough to overcome the friction, and the object will stay on the tablecloth. If it's a large enough force, we can say precisely how large must be greater than equal to mu times m times g. If that's the case, then the tablecloth will slide right out, and the object will stay on the table.
So, I didn't really understand all that mumbo-jumbo you just said, but what you're saying is the harder I pull, and if I pull downward and not upward, then it'll work better?
That's basically the idea, right?
All right, well, I'm going to go try this again.
Good luck.
Thanks.